meter and 1 meter. So draw shear moment diagram. Next, this is V shear. Moment. The next question, first the next question. Added force here. Okay. Okay. Same geometry. One. So first solve this one. Then we go to that. But let me solve the first problem. Then you solve the second problem. The first problem, I keep drawing CD on the big entire thing. The reaction did 2K this way. No vertical load, no external component. Right, but we have X, Y, both of them. The only thing you get is the 2K2 balance the other one. Right? So if you cut it from here, you're going to get only the 2K this way and MX and DX, the left system. So MX plus 2K is equal to 0. That means MX is equal to negative 2K. And D of X is 0. So you have MX is negative 2K. And V of X is 0. What about from here to here? That's what I wanted to see. It's 0, both of them. You see, take this right part. The right part, you only have MX, VX. Both of them add up to 0. So you have the same line to the end, and the moment is also 0. That's your shear moment diagram. Okay. Okay, let me solve it myself. First, external reactions. What do external reactions? I have compound here. 3 compounds here. Let's say point A, B, C. MA, AX, AY. So for the entire system, obviously, A is 0, I don't need to write it. AY minus 1K is equal to 0. Summation of A, MA, negative 2K, negative 1K times 2 is equal to 2. That means MA is 4K. Right? So here we're going to get the 4K and AY 1K. What's wrong with that? Now from here to here, if you take your X from right and you derive from here, you get MX dx 1K 4K, and this length is X. times x. So if you write moment of freedom like that, you get positive mx is 0, negative 1k times x plus 4k is equal to 0. That means your moment is equal to 1k x minus 4k. What would be my shear? There are two ways to do that. The first way, summation of force in y direction 0. So negative dx plus 1k, 0. So dx is equal to 1k. What is the other way? Thank you. Take the derivative of that. E and dx is 1k. So shear is equal to 1k. So let's try it here. X, V, M, use red. So moment is a line. You see how many points do I need to draw a line? 2, beginning, end. This is 1k. So let's draw shear, 1k. So positive 1k. And the moment is equal to, when you put x0, you get negative 4k. So you write here, when you put x is equal to 1, then you get 1 minus 4, negative 3k. There you go. That trapezoid is your omega. Now, I go ahead and continue cutting from here to here. So what do I get from my FED? Right here. So you go a little bit further, cut it. You see you have 4k, 1k, and now you also include that 2k to y because we're cutting from here, and this is the one on the left is your system. You could take the one in the right. So you include that 2k, put it here. Put that 2k here. And then here you have mx. X, V of x goes down. That's to complete FED. Look, as you have noticed, we cannot solve anything without going through the 5 steps, every single time. That's the reason in vector studies, I mentioned the 5 steps very specifically. Every time we solve a problem, I wrote it on the right corner of the whiteboard. So that's the first step. Second step, FED. And now, third step, what is FED? Summation of moment at that point. I know that, well, if I get moment, I get shear too, right? So I don't waste my time with shear. I say summation of moment here, 0. So you get mx, positive, is 0, right? And then negative 2k, negative 1k times x, and plus 4k is equal to 0. You know that from here to here is x. Again, when we continue this x, we extended this x. So if I solve for mx, I get mx is equal to
1kx minus
4k minus 2k, 2k, take it to the right, negative 2k, plus 1k x. Do not forget the case. Sometimes I put it for this and I forget to put it for that. So it becomes negative 2k plus 1x. And then when I put it in the calculator, I say negative 2000 plus 1 times x. And I see because 1 times x, x is between 0 and, for example, 2. Is it still a number? So still you get negative 2k. You don't see any line, any change. They can easily mess up your calculation. So let's write the second part. How many points do I need? 2. At x, at x equal to 1, what do I get? Negative 1k. So we have kind of, this was negative 3. What was that, the first equation? Negative 3. And then you go, you have a little jump here. Like that, you see? You go to negative 1, and what do you get at x equal to 2? 0. So here, you have 0. So you have another line. Like that. You see that? What about shear? Take the derivative. dm dx is equal to 1k. Well, when I gave that, I saw one student or the other did it like in minutes. That's a good sign. Draw shear moment diagram for this thing. And axial load. So draw, the question is, draw shear moment and axial load diagram. So you need to draw 3 diagrams. Well, first I'll find the external reactions. First I'll take my system. I'll take this one as a system. This one, system to system 1. If you don't do this kind of thing, you can't solve it. This is not what logic. You have to take system. Otherwise, you just memorize particular examples of a solving class. You won't be so general with solving the problem. System 1, system 2, and system. Let's take these both together as system 3. I could take this as system 3 and make this as system 4. In fact, let's do that. Both of them same. I do both things. Right, so you have system 3 for this, system 4, and I'll also take the entire thing of system 3. Now FED. So let's take this point A, B, C. AY, AX, MA, 30, sorry, 3K, 30 degree, 3K, and here, let's say this cable, and this cable is cable number 1, right? cable number 1, and let's go say this cable is cable number 0. We can put some labels on it, cable 1, cable 2, cable 0, whatever you like. Cable A, cable B, cable C, whatever you like, right? So, what should I write here? For FED of this, the force in this cable, and it's the same cable, so T2, right? Then I go draw, this is pretty much, and because it's a pin, you don't have a couple moment there. You can easily rotate. So you only have T2 here, VK 30 degree, and reaction at the wall. That's done. FED for system 1. Now go ahead and draw FED for system 2. Which one is system 2? This one. So you have a pulley here. There is a force here, another force here, and another force here. That's all. There is no couple movement. Why? Because there is no friction. There is no weight because your pulley is massless. If your pulley is not massless, I'll say this is like 200 kilograms. There is no pulley that is 200 kilograms. For example, if I say that, then you have to add one mass at the center too. Right? So what's your right here? T2. Thank you. Here? T1. The frictionless massless, right? Now I'll go draw FED for system 3. This pulley right here. Again, I'll have the same pattern. What's your right here? T1. Here. T1. Here. T0. If I separate that. If I separate that, it's T0. And then you have a weight right here, that in the weight you have a T0 going up, the same thing, and also you have W, right? This complete breakdown of all systems and all, including all the PDs. Now here is the thing, if I take what he says happens, if I take these two as a system, right? So in fact, if you draw it like this as a system, dash line, and it's going to cut this W here, there you go. You can see that external forces right now to my system. What are the external forces? T1 is internal. T1 and weight, right? This becomes completely internal, so you can just ignore. That's the reason I say I took the entire thing as system, because that T0, you have one here up, down, one here up, they will cancel out. You write summation of force in what? It becomes internal forces. So then you can simply do either way. Doesn't really matter. So let's go ahead and solve. So when you do FEDs, then the next step is the equation and solve. If I solve that, what do I get for T0? The weight. Then what do I get for T1? Half the weight. So T1 is W2. What do I get for T2? Half the weight, which is 1/4 of the weight. So T2 is 1/4 W over force, 4, which is 309.81 times 4. 735. Right? 735. Then here you have that. 735. So let's solve this system. I already wrote, I didn't write the equation, but I know that I will keep solve the equation all the way. Now the equation for this part is summation of force. So these are equations for system 1. Now I want to write summation of force in x0. That will give you AX. This is Y, this double moment plus 3k cosine 30 is equal to 0. Summation of forces y0, that will give you ay plus 3k sine 30 negative T2, which is 735, is equal to 0. And summation of moment about any point, 0. What point do you take? 8. So if I take 8, then I get MA. This will cancel out. Then the moment of that is 3k sine 30, the vertical component. You remember, to compute the moment, we have to first break it down, move the component, get the momentum, and compute it. So 3k sine 30 times 1, and it's positive. Now finally, the moment of this guy is what? 7 is positive, negative 735 times 2 is equal to 0. Now solve it. AX is equal to
negative 2,598.
negative 2,500.
It'd be closer to 2,600 after happening.
Negative 2,600. Right? AX. Double check the numbers. I use your calculator, so you've got to get the right number. AY is equal to, that is 1.5K minus is almost like around 7, 35, something like that. Put in calculator,
AY is equal to 764.
764.
0.25 and it's negative.
764. And it's negative, right? And it's negative. Okay, yeah. It's good. And then solve for NA. NA is equal to
Negative 28.5.
negative 28.
0.5.
You sure?
About negative 3.
Oh, that's K,
Close.
2.8 K. Let me put a calculator.
I got negative 30.
Yeah. Negative 30. Please double check this also, these two. Alright. So assuming this data is right, then I'll go ahead and write it here. So for that, I'm going to have the force here, which is 735. Going down is already here. AY is equal to, goes down, and AX is also goes to the left. So AY goes down, equal to 764. AX goes to the left, 2,600. And MA is negative 30. So it should be this way. 30. That's your complete loading. Now go ahead and draw the actual load. Now how many plus do I need? 1, 2, 3. So you can just extend this like that. Plot number 1, plot number 2, plot number 3. How many intervals should I consider for that? 2. X, Y, X, again X, X. And this is axial force and shear load and bending moment. So I do the regular procedure. I take my X from there and cut it between 0 and 1. What do I get? I get 30 already here. 7, 64, 2,600. Here X, axial load at point X, shear load at point X, and bending moment at point X. That's all I get. So that's all I get for this one. Right? So I go ahead and write the equation. Summation of forces in X 0. Look, this time I did not forget the axial load. Because what? Do you have a question? No question. I know that there is something that there is a mechanism that causes the axial load. So I included that. So for that I get 2,600 with negative, this one Y, this one couple moment, Y couple moment, then plus, and at point X is equal to 0. Summation of force in Y, 0. That means that you get negative 764. This is X couple moment, X negative Vx, V of X is 0. And summation of moment at any point, we shall take X 0. Then I get positive Mx, negative 30. This one, what about moment of 2,600? It goes through that point, so the moment R is 0. And then the moment comes from 764 times this distance, I know that it's X times X with positive is equal to 0. So M of X, negative 30, this was 0 plus 7, 64 times X is equal to 0. Now I solve it again. You see, remember 5 steps. Then at one point do the equation and then you solve. If I solve it, Nx is equal to 2600. E of X is negative 764, and M of X is equal to negative 764 times X plus 30. Got it? What should I do from here to here?
7,600.
That's positive. So you say 2600 positive. You see it's positive. It's positive, negative. The shear load is negative 7. This shear. 764 negative. And the moment is a line. Look, derivative of moment is what? The shear. It's still valid, right? So if I want to draw that, what do I get at x0? Positive 30. Positive 30. What do I get at x is equal to 1? So you have a line that somewhere here the bending moment is 0. That's the interesting thing. So you have positive and here negative. Like that. And at this point is negative 734. Now we go to the next interval. The next interval, I'm free to take either this side or the one on the right side. Both should put exactly the same plot. Again, the equations may look different, but when they plot it, they're exactly the same plot. So this time I take the one on the right. Okay? So if I cut it here, I know that from here to here nothing changes. Right? So if I cut it there, then I'm going to get this right here. This right here. I'm going to get 735. And then this point, you have an NX going this way, DX going up, and MX bending upward. Positive. That's what you get for every of that one. So what can I say about axial load? Immediately 0. Right? Summation of force in X 0. So you put a 0 here. What about the shear? Plus Vx negative 735 is equal to 0. So the shear is positive, right? So the shear is 735. Positive. What about bending moment? Sure. 735 times what is your moment arm from here to here, and what is from look, I'm cutting it from here to the right. So x is from here to here. So the length of that is the entire length 2 minus. So if you write moment equation about that, you get negative mx. You see from here to here is 2. The left part was x, so that's the 2 minus x. So write summation of moment at point x 0. What do you get? Negative mx. Right? 0, 0. Then negative 735 times 2 minus x.
It's positive, right?
Yes. Is equal to 0. So mx is equal to, take it to the right, is equal to 735 x negative 2 times 735. Just by solving that. There you go, that's the equation. Mx is equal to 735x Yeah, this goes to right, mx is equal to 735 times x negative 735 times 2. So if I want to draw it, I know it's a line. So how many points do I need? 2. First put x is equal to 1. What do we get? Put 1 here. You get 735 times 1, negative 2,735. You get negative 735. Right here, almost. Right? And then you put x2. What do you get? 0. There you go. Beautiful. You see, it goes from positive at some point to 0, and then it goes back to here 0. The shear is discontinuous. Why? Because you have a vertical shear. If you had a coupled moment, what curve would be discontinuous if you had a coupled moment there? The moment curve, right? So when you have anything like shear, your shear diagram, you should have a jump like that. And also look, you have a normal force produced here, right? So you're going to have a jump here. Yeah.
You confused on why the axial load is positive.
Well, when you find the reactions, right, this 200, 2,600 to the left. Now when you cut this part and draw FD, just do that. So you have 600 here, and some other couple moment. And then you shear load, the directional positive shear load is always tension. That's the reason for the left part I draw it to the right. For the right part I draw it to the left. Look, for the right part, because the default positive is tension. Now, what is Nx here? Summation of force in Nx is what? 0. So positive Nx, negative 2,600 is 0. So Nx is positive 2,600. Look, the sums are important. When you do machine design, machine component design, or if you are mechanical, or if you do a structural analysis, if you are civil, then you see that really sound important. So next class, the teacher told me that they're going to have a detailed exam. So instead of continuing to 9:15, I want to terminate this at 9:05. So we still have 4 minutes. So let's say I want to give you a meter here. You still have opportunity. Still have opportunity. Give yourself the meter. You still have opportunity. Draw moment diagram. Distances are 1, 1.